Okay everyone, so this video is going to be introducing you to the microbit and the online Python, MicroPython development, IDE. This is known as the Integrated Development Environment that you see on your screen here. To access this online Integrated Development Environment, or IDE, you simply visit the python.microbit.org /v/3/project. That takes you to the screen that you see currently. Just to orientate ourselves a little bit, what you see over here, this is our file menu. Okay, it also has our reference code that we'll be looking at a little bit later on. This has our project details that we'll look at a little bit more later on. We can toggle this to give us some more screen space. And then over here we all have our code. So this is where our code is written here. So this is where we write our code. Over here is the microbit simulator. So this simulates the microbit. We are going to be using the physical microbits very shortly, but this is a simulator for what a microbit, what the code is doing if the program was uploaded to the microbit. So you'll learn more about the microbit and exactly what it is a little bit later on, but it's basically a little microcontroller that has built into it a whole bunch of features that we can code and upload our programs to this little microcontroller. Down here you see some different functionality that we can do with the buttons or with the different microbit features, and we'll look at some of those a little bit later on as well. Probably most important up the top here is we have our project. So you need to make sure you title your projects or else you will get lost and confused. So we will start this as our first project of Hello World. You can see that names the project Hello World. And if we have a look at this, code comes with the program. So when you boot it up, you'll see this code here. The first line of code that you see here, first of all, this hashtag that you see here, this is known as a comment. So this hashtag, whenever you see the hashtag and then some text, that basically means that this is not executed by the computer. It is simply there for us as humans to understand exactly what is happening in the code. So you can see this comment here, the computer doesn't know how to interpret that, and it just skips over it. So whenever it sees a hashtag, it skips over that line. You can see what it does do though, is it explains what the first line of this code is, which is to import a module which is known as microbit, and it imports all the functions that are associated with that. So we'll be using a whole bunch of different functions and methods that come with the microbit module in order to program the microbit. And that's all part of this MicroPython. So you really don't need to know much about what's happening up here. What you do need to know is what's happening down here. So what we might do is we can see here that it says code in a while loop, code that's in a while true, which is known as a while true loop. This repeats forever. Okay, so this while basically means while true, and basically this is a condition, so it checks to see if this is true. True is always true, so while true means this runs forever. Okay, if I run this program, you can see here that it's going to display an image of the heart. That's what display.show does, image of a heart. And then it sleeps for 1000 milliseconds. That's what this sleep here means. Pauses for 1000 milliseconds, which is a second. And then it will scroll just the word hello. And this repeats forever, because so the code within this while true loop will repeat forever. If we were to remove the while true loop, so let's go ahead and remove that, and let's just do this. So we've removed the while true loop. This will run the picture of the heart for a second, then display hello, but then does nothing. So the program is no longer looping, okay, because we removed the while true loop. So any code that's within the while true loop will loop forever. If you want some code to not loop forever, then you need to put it before the while true loop. So let's just say I wanted to, let's say display.scroll, and and just say outside, just to show that it's outside the loop, or let's say first. Okay, so this will run first. So the programs will run sequentially from top to bottom. Okay, so it'll import this first, and then it's going to display first, and then it's going to get into the while true loop. So if I run this, we should get the word first come, and then the heart, and then the hello, and the heart and the hello will continue to repeat forever. This first will not repeat at all. Okay, so this display.scroll first, that will not repeat at all because it's outside of the while true loop. When I say outside of the while true loop, you can see this indentation. That's very important when we code in Python. Anything indented means that it is part of that particular loop or that particular conditional check that we'll look at later on. So you probably will figure out here that if I wanted to have some code after the while loop, let's say I want to say display.scroll after, you'll notice that this is grayed out, and that's because the program will never actually get down to this line of code. Okay, it's not within the while true loop because it's not indented. Okay, and unlike the display scroll first, that happens before the while true loop. This while loop true loop loops forever and never actually gets down to this line of code here. Okay, so if you want something to happen once after, there are ways to get around it, but for now you probably can't do that. Alright, so let's just show you some different features. Let's remove the image here, and let's just show you the difference between display.scroll. We know what display.scroll does. We'll remove that as well. Okay, that just says hello. We can change the text in here. So this is a string. We can change that to hello world, and now it's going to scroll instead of just hello. It should scroll hello world, and you can see that's doing that. Another option that we have is show. So instead of scrolling the text across like that, we can do show, and now it will kind of display each letter like that instead of scrolling them across. As you saw before, we can display images on the LEDs, such as using .show. So I can change this to capital I image, and you'll notice here that if you start typing, you get this autocomplete. Okay, so let's just, if I type I and then M, you can see it's got image there. I can just click on that, saves me having to type it. So then I can do dot, and you'll see when I do dot, this accesses all these different images that are kind of built into the microbit. Okay, and I can use any of these just by clicking on it. The first one I'm going to do is a skull, so I can just type SK, and then you can see skull image. And if I was to run that, you can see that while true, it's going to display image skull. If I want to display the skull and then a happy face, I could try something like this. But if you look at it, you'll notice that it's only displaying the picture of the happy face, and it's never actually displaying the picture of the skull. And that is because this computer is operating very, very, very quickly. There is a good chance it is actually showing the image of the skull, but it's happening so fast that we don't actually see it. And that actually means that what we need to do is put in some pauses so that we as humans can actually see what we want to see. Because right now it is just constantly displaying the image of happy because it's running very, very quickly. So we can do that by putting in a sleep command, and we just simply say sleep like this, and you can see it tells us what this function does. It says waits for n milliseconds. So whatever the number we put inside of the round brackets will be how many milliseconds to wait. So if we do 200 milliseconds, and if we run this now it's displaying the image of the skull and then pausing for, what's that, 200 milliseconds. And then it's displaying the picture of the happy face, but then it's immediately showing the skull again and then pausing. So again, that's happening so quick that we don't actually see the happy face at all. So we need to put a pause in after the happy face as well. Now you can see that it's moving between those two different images. Now that we've got, and it's showing a picture of the skull, pausing for 200 milliseconds, showing a picture of a happy face, pausing for 200 milliseconds, and then repeating from there. Some other things we can do is we can also make our own images. So if we go to the reference, in display, you can see we have the option to make our own images. So I can copy and paste this, or just drag and drop this block of code. Okay, and if I was to, let's remove the happy face, or let's actually remove all of that. But if you can see that this is how this currently looks, and this is kind of like a matrix where each of these represent one of the LEDs that you see here. 0 means the LED is completely off. 3 is kind of like means it's on but not fully on. Okay, it's kind of like a brightness setting. 6 is more bright, and then 9 is the most bright. So for example, if I change this row here to 99999, you can see that the top row is fully bright. Okay, if I change the bottom row to, let's say, 5, 5, 5, 5, 5, you can see that they're all on, but they're not as bright. Okay, so you can actually change the brightness settings just by changing these numbers here, and kind of make your own image using that particular bit of code there. You don't really have to worry about how, like, typing this out. You can just kind of drag and drop this particular thing. You can also show specific LEDs. So what we can do is I can do display.set pixel, and also you can just do enter and it will autocomplete as well. And let's do 0, 0, 9, and you can, as I do that again, you can kind of see this is the X, the display column, this is the Y, and this is the value, so the brightness. So if I do this, you can see X is 0, so X is probably the horizontal axis, and Y is 0, and this starts at 0 at the top here, and then 9 is the brightness setting. So if I was to change this to 1, now you can see on the x-axis it's 1, so it moves across 1. If I was to change this to 1, now on the y-axis it's at 1, and again the brightness is at 9. Okay, you could, let's say I wanted to make it this particular one here, well that would be on the x-axis, that would be 0, 1, 2, 3, 4, so this would be 4. And you can see I'm turning on that LED, so you can target particular LEDs and turn them on or off. So what we occasionally want to do is we want to save our work, and when you're working on your tasks you want to save your work. Coming back to our side menu here, you can see our project. Now for most of our projects we're only going to have one file in our project, which is simply the main.py file. Okay, that's the default project name. So to save our file, none of your code will save on, this is not a browser that saves your work, you need to manually save. So to manually save, there are two types of files you can manually save. The first is if you press the save button, like that, that will save into your downloads what's known as a hex file. And that means this is the file that you actually upload to the microbit. So when we actually start working with the microbit, the type of file that we'll upload using USB to the microbit will be a .hex file, because that is written in hexadecimal binary code. And we can go ahead and look at that hexadecimal binary code if I show that in Finder. And if I open this with TextEdit, what you'll see here is this is hexadecimal code. It's basically a whole bunch of zeros and ones. Okay, they're not all zeros and ones because they use a particular type of numbering system called hexadecimal, which is kind of like our decimal number system, but instead of having 10 digits, it uses 16 digits, including like A, B, C, D, E, F, up to F. Again, you don't need to know too much about this. All you really need to be aware of is this is what the computer, this is what the microbit reads as this program. So when the computer reads the program that we've uploaded to it, this is what it's reading. Okay, now we obviously can't really interpret this. This is not made for us. This is made for the computer. So we need some code that we can read and can interpret. And that's where this other button is. So next to the save button, you'll see the 3 dots here. And you'll see it says Save Python Script. So if you click Save Python Script, and if I open up that file in my text editor, you can see that unlike the hexadecimal code, this is written in English or written in human readable. So I can read this code and understand exactly what the program is doing. And this is the code that we're writing as humans. So it's always good to when you upload your work, upload it as a .py file, so that's the extension for this particular type of file, because that is what we can actually read, not the hexadecimal file. You do need the hexadecimal file though when you want to upload your program to the microbit. So some other buttons here is if you want to reset a program once you've saved. I should say that what you can do is if I hit reset program here, okay, that takes us back to the untitled project. Okay, gives us back exactly what it was at the start. But if you want to open up your program and continue working on it, you can see you've got a few open buttons. If you just type on open, and you can open up either of those hexadecimal files. I need to clean up so here's Hello World 3, and I can open that up, and here is my program, okay, that I was working on just before. So you can open up a hexadecimal or a PY file and continue working on it, but just note that nothing auto-saves. So you need to make sure you save your work as you go, and it's probably good to save that into Google Drive so you've got your programs saved as backed up. They will automatically go to your download, so you'll need to move them there. Alright, so to make a new project, as we said, you just click on Reset Project, and then you can title your new project up here.